Okay, folding an origami buckyball. So we start off by getting the equilateral triangle that we figured out how to fold mathematically in the prior videos. And we're just going to fold it in half for each side. So nothing too tricky, just folding each equilateral in half, and then we fold the points down to the middle line so we get a smaller triangle that'll appear. We unfold it, and what we're going to do now is when we have one of the points folded down, we're going to take this point and fold it back out. Now, where's the proper place to go? Well, you'll notice that there is an intersection of these three lines here. And that's where we're going to fold it to. Fold it there, and we repeat for each side as such, and we get a little star. Now, this isn't necessary, but I like to just make it a bit more secure by locking it by flipping this flap underneath, just so it's nice and locked. So we have this star, and we take our points of the star, and we fold them in towards the middle, so we get something that I think looks a lot like the radioactive sign. And now we should have a triangle. Finally, we crimp it, and crimping is just shaping it into what we want. That's all it is. So we just fold it down on the outside so we get something that looks like that. Triangle that's then squished down into these 3 points. Now, if we take 2 of them, you'll notice that there's a slot and a socket, and they just slide straight into each other. And the more exact your triangles are, the closer these 2 will be and the better join you will get for them. Now you'll need 60 of these to make the buckyball that we showed in the video. You could make a cube using 8. You could make a dodecahedron using, mental math, I believe about 24. You can experiment that for yourself, but as for the buckyball, you'll need 60. So go home, try this if you want. It's pretty neat, really fun thing to build, a lot like Lego, and I hope you enjoyed these videos. This is a pretty neat artistic and mathematical object. It's called the stellated icosahedron, which is a fancy mathematical way of saying it's a spiky ball. The actual spikiness of it comes from the icosahedron.